All right, so last class we talked about rate of change and finding slope, and we looked at it with a table, and we looked at the change in y. So last class we were saying how are my y's changing with how my x's are changing, and we're going to do the same thing now but with a graph. And so notice that there's 2 points that have already been kind of highlighted for you. There doesn't have to be, but what we look for are spots where my line crosses what we call lattice points, or lattice marks, and that's where we have like grid marks. So like another spot that we could have, oh, actually this graph doesn't have any other ones. On this graph, another point we could use would be like right here or right here. So points where I know definitively what the x value and what the y value is. And so we're going to do a change in y over a change in x. So similar to how we did that with the table, we're going to go ahead and mark up our diagram on here. So my change of y, I'm going to start down at my bottommost point all the way to the left, and I need to go up all the way to here before I can go over to get to that next point. So your slope is kind of like your set of directions. It's telling you how you're moving along your line. And so now I'm going to count those spaces. I have 1, 2, 3, 4, 5, 6, 7. So I went up 7, so I'm writing plus 7. And then I'm going to the right, 1, 2, 3, 4, so plus 4 because I went to the right 4. What we're going to remember when we're graphing is rise over run. I have to rise up before I can run. So I want you to write over here, rise over run. And so my slope for this would be m equals 7 over 4, or 7/4. And again, that's because my rise was how I moved vertically. My run is how I moved horizontally. All right, let's try another one. Again, I like to start, whenever I'm doing these, I always start with my rise or my run. And so I usually start all the way to the left, just like we read a book. You don't have to, and I'll show you why in a minute. But I usually start to my whatever point is furthest to the left. And in this case, I'm going to need to move down and then to the right. So I draw it out first. Notice I went down 1, 2, 3. So subtract 3 or negative 3 because I went down 3. And now I'm going to the right, 1, 2, 3, 4, 5, 6, 7, 8, 9. So plus 9. So when I find my slope, I say m equals, again, it's my rise, which is this blue line, over my run, which is this yellow line. So I'm going to do my rise, which in this case is negative 3, over my run of positive 9. Now we always want our slope to be in lowest terms. So I know 3 divides into both 3 and 9, or 3 is a factor of both 3 and 9. And so I get a negative 1 over 3 for my slope. So notice now, if I were to start at this point again and go down 1 to the right 3, I hit another point on my graph. I could go down 1 to the right 3, I hit another point. And so I can describe this in 2 different ways. I can say I'm moving down 1 to the right 3, or I'm moving down 3 to the right 9, because mathematically they mean the exact same thing. It's kind of like walking down a set of stairs and taking 1 stair at a time, or walking down a set of stairs and skipping 2 steps each time, right? You're still getting down the stairs. The stairs are still at the same slope. You're just kind of moving down them in a different way. All right, these are our 2 unique. So we saw a positive slope, and notice this is increasing from left to right. We now see a number 8, a negative slope. We're decreasing. It's like we're sliding down a hill. Whee! This guy, we're like climbing up a mountain, right? Now we have our 2 situations that are a little bit unique. We're still going to look for our rise and our run. So I'm starting with my point that's furthest to the left, and I try to rise up, but I can't rise up at all. So I'm not going up anything. I'm just going to the right, and that's it. So 1, 2, 3, 4. I went to the right 4 units, but I didn't rise up at all. So I'm just going to go ahead and put a 0 there because I didn't rise up anything. So my slope would be 0 over 4, which is just 0. And this is a horizontal line, which means I have like a 0 incline or a 0 slope. For number 10, I can do the rise. I'm going to start my lowest point. I'm going up 1, 2, 3, 4, 5. Use a different color. I'm going up 5, or you could say down 5, right? But I'm not going left or right any, so I'm going to put a 0 for going left and right. And so when I do my rise over run, I say my rise is 5, my run is 0. And we talked last class about how we can't divide by 0, right? We can't break something up. If I physically have objects, I can't break them up into 0 groups. And so this is undefined. All right, I want you to please try 11, 12, 13, and 14. I'm going to go ahead and post those answers online, so I want you to do them. And then go check Google Classroom to see what those answers look like. And that is all you guys are doing. Oh, no, we have this guy too. Perfect. Sorry about that. So graphically, we've taken a look. We've looked at it in a tabular way. The last way to look at our slope is to look at it with a formula. So our formula for slope, and this should look pretty familiar from last year, is m equals y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. So again, change in y, which is my rise, over my run, change in y over a change in x. Right? So everything's exactly the same. We're just looking at it from a different lens because we're given different given information. So when I'm given 2 ordered pairs like I have below, I'm going to use my formula y2 minus y1 over x2 minus x1. When I'm given a graph, rise over run is really quick to remember. When I'm given a table, we're looking at that. How are my y's changing, and then how are my x's changing? So let's take a look at number 15. The first thing I want you to do, and I don't want you skipping steps with this just yet, because it's really important that mathematically we're following the steps so that we don't make any of those silly little mistakes that we love so much to make. So I'm going to go ahead and label this first ordered pair x sub 1, y sub 1. And what's important is that those subscripts, these little baby ones, always tie together with the same ordered pair. Doesn't matter which ordered pair, but it has to tie together with the same one. So they have to be paired together. This one's going to be x sub 2 and y sub 2. I'm going to write down my formula. And that's an important step because we're learning this formula. This is a formula that will not be given to you. And so it's super important that this formula gets ingrained into your brain. We use this formula all the way from 7th grade math all the way through into college. Like, this doesn't go away. AP Bio uses this formula. AP Stats uses this formula. I mean, environmental science is going to use this formula. This is a foundational formula for all of our math and science. Physics is going to use this formula. All of you will take physics your junior year. And now I'm just going to put the numbers where they belong. So notice that y sub 2 is 3, so I'm going to put a 3 where it says y sub 2. Then I have y sub 1 is 1, so I'm going to go ahead and put a 1 where it says y sub 1. Then I have x sub 2 is 4, so I'm going to put a 4 where it says x sub 2. And x sub 1 is 1. Oh, that didn't work. X sub 1 is 1. So I'm going to put a 1 where it says x sub 1. And now I'm just subtracting. 3 subtract 1 is 2. 4 subtract 1 is 3. And I'm done. Let's try another one. I label my points, or I label my ordered pairs. x1, y1, x2, y2. I write out my formula so that it gets drilled into my brain. The more times you write out a formula, the less likely you are to forget it. All right, and now I put things where they go. -2 subtract 4. 10 subtract a -2. Notice we did this at the beginning of the year. When I'm subtracting a negative, I make a point to put that negative in parentheses so that I don't lose a negative sign. So I have -2 subtract 4, which is -6, divided by, when I subtract a negative, it turns it into addition. 10 plus 2 now is 12. Again, the factors of 6 and 12, the common factor, the greatest common factor between 6 and 12 is 6. So I'm going to divide 6 by 6, and I'm going to divide 12 by 6, and I get -1/2, or -1/2. All right, let's do 2 more together. Again, label your ordered pairs. M equals, I write it down, y2 minus y1 over x2 minus x1. For some students, it's really helpful if you need more of like a visual cue, and I think some of you guys kind of do this with equations, so it might help. For the y's, they go over to make sure that they kind of see what's going on, so they'd say -5 minus 5. And then for the x's, they go under. So -8 subtract a -4. And that just kind of helps them to make sure they put things where they belong. So we have -10 because we're going more negative. A negative subtract a negative is a positive. So I'm going to turn that into a positive. So I have -10 over -4. A negative divided by a negative is a positive. So I know the negatives are going to go away. 2 is the greatest common factor of both 10 and 4. So we have 5/2 as our final simplified form. All right, let's look at number 19 together. And then I'm going to have you do 18 and 20 on your own and check those on Google Classroom as well. So again, label your ordered pairs. Write out your formula. All right, and again, 9 subtract 9. 3 subtract 5. 9 subtract 9 is 0. 3 subtract 5 is a -2. 0 divided by -2 is 0. And we're done. All right, so you have a Delta Math to work on now, and then we will regroup next class and look at some applications of these slope problems. See you all next week. Yep, I'll see you all on Tuesday.